reminder, when you're asking questions, just a reminder, every week I need to remind everyone to put your finger on touch, the red light, keep it on while you're asking your question, and then release, and then Paul will come up with a scintillating answer to the question. And that is for our people out in webland. And we are here. Okay. So, following your directions. So today we have Paul Bender, who's a Ph.D. candidate here in the School of Urban Studies and Planning, one of our distinguished MERP graduates as well. He is speaking, his topic is out here, but I will repeat it. Creating, sharing, and updating regional, state, and national transition frameworks, Centerline data geometry. It's all yours.
Okay, yeah, the title is quite a mouthful. I have it up here on the screen is also to make sure you're in the right place. I realized as I was preparing this presentation that there's a lot to cover, so I think I labeled this part one, the big picture. So hopefully I'll be coming back in the spring and giving a more detailed presentation on the research that will hopefully become my dissertation. So today we're going to go over the big picture. Wasn't sure who was going to be here, what the audience was going to be. So we're going to kind of go through step by step. I'm going to give a little bit about my personal background, then an introduction to the topic, and we'll talk about the research that I've been doing with Professor Ken Duker, who unfortunately isn't here. He has the misfortune of being down in Palm Springs, California. So then we'll talk about some conclusions, and then we'll open it up for questions and comments. And I guess if you have any pressing questions you want to ask during the presentation for clarification, feel free to ask. Some personal background, Philadelphian. I got into transportation partly as I rode the L and subway to school in Center City, Philadelphia. Had a big influence on me. I almost have a BA in physics from Reed College, but I do have a BA in geography from Millersville State University, and I'm currently a Portland State University MERP and PhD student. Haven't officially gotten my MERP degree, so.
I was generous.
Thank you. And some of my work background that got me into GIS and GIST. I worked for Geosystems towards the end of my bachelor's degree. Geosystems is now MapQuest. They started out as a cartography house. And my big project there was working on the AAA Internet Triptych program, basically coming up with digital map base that would allow AAA to give out triptychs much more easily, and that has now become MapQuest, which most of you are familiar with. I also delivered pizzas for Pizza Hut for 5 years, which, believe it or not, had a big influence on some of my current research, updating transportation features, because I was delivering pizzas in a rapidly developing area, which had a lot of new roads that weren't on maps. So we'll get to that later. And my future direction, a little tongue-in-cheek, is to become the Amtrak ACELA Professor of Transportation, GIS, and Regional Studies with joint appointments at Harvard, MIT, Columbia, Rutgers, Princeton, Penn, and Maryland, all made possible by the ACELA train. And as you can, if you're all familiar with Ultraman, put this in there because I'd have to be Ultraman to accomplish that. So. Unfortunately, I didn't get to ride the ACELA train. I just got back from the East Coast, from the TRB conference, which a number of you also attended, but didn't have a chance yet to ride the ACELA train. So hopefully I'll one day do that. Yes, question?
Paul, what's the ACELA train?
Oh, the ACELA is Amtrak's Northeast Corridor high-speed train. It's basically our attempt to catch up to the TGV, the Trans-Europe Express, and the Japanese bullet trains. So. Has anyone ridden it, by the way? Yes. Yeah. How fast does it go?
It's supposed to go like 160 miles an hour.
Okay, that's pretty good. Yes.
I heard you save a half hour and pay double.
What's that?
I heard you save a half hour in time
Oh.
and pay double for your ticket.
Really? From but if you go from Boston to D.C., I'm sure you.
Boston, DC.
Okay. Well. Okay, so a little introduction here. I'm going to talk about the research history and background, how Professor Duker and I have been involved in an ongoing project that's gone through several mutations. I'm going to talk about what is a framework. Most of you probably aren't familiar with that and how it relates specifically to GIST and transportation. Talk about the Orbits team that we started working with. Then we moved on to IRIC, and our current research was based on work for the Washington State framework. Just a quick background on GIS, Geographic Information Systems, for anyone who's not aware of it. Basically, we're talking about the integration, manipulation, and display of digital maps and map feature data. So we're marrying maps and the data about the maps or the whatever features. And here I have a Centerline map that displays pavement condition data. So this is one of the most common applications of GIST and Centerline data. And I'll talk about this is the GIS Framework Layers. Basically, this is both a national and state level effort to create 7 what are called framework layers, and these are the key layers of geospatial data that the federal government is trying to provide for the entire United States. And we're going to talk mostly about, or just about, transportation today. What is a street centerline? Basically, it's a digital representation of the road carriageway, and it's pretty key for location analysis and network routing applications. What you most commonly find used is for address ranges, for most delivery and location services. This is how the Centerline files pretty much got started. The U.S. Census Bureau developed what's called the Tiger Centerline files back in the 80s, I believe it was, and it stands for Topologically Integrated Geographic Encoding and Referencing System. But I'm not sure there are many people who actually remember that. It's just commonly referred to as Tiger. So, and this is a display of the basic Tiger Centerline. The first Centerlines weren't envisioned for transportation. They're basically to delineate census block tracts. So as you can see, they're kind of fuzzy, and that's also because of I blew it up. But over time, we've been trying to enhance these, and this shows what a tiger line basically looks like. Not very pretty, pretty geometric. This is the I-405 interchange just south of us, I-405 and 5. And this shows kind of an enhanced version, what happens when a number of vendors, national vendors, take the basic Tiger file and enhance it. They try to improve the geometry, and they add attributes such as directions, which you see here in the little arrows. So here's the big question you're probably all asking right now. Why do we want to share and update transportation framework data? Basically, there's kind of two problems or two issues. The first is that there's a spatial overlap of Centerline geometry and data needs. And that takes 2 forms. There's a horizontal overlap where you have adjacent jurisdictions, whether they be cities or suburbs next to each other, or counties, or less frequently states, which are adjacent to each other. And unlike parcel data, streets cross boundaries, roads cross boundaries, transportation features cross boundaries. So we have to be able to share the data on both sides of a boundary because it's still the same feature, unlike a parcel, which is unique on each side, pretty much, although that's not always true. The other big issue, and kind of more challenging, is the vertical overlap. And here we have local, state, and federal roads, different jurisdictions, different types of jurisdictions that are responsible for roads in the same area, same spatial area. For example, in Multnomah County, we have city roads, county bridges. Out towards Mount Hood, we may have Bureau of Land Management or U.S. Forest Service, and we have ODOT roads. So they're all kind of in the same area, but they have different owners and maintainers. So we have to be able to share among these different jurisdictions that overlap in the same region both data and geometry about the center lines. And then on top of that, everyone wants to have the best available data. And this is really being driven by emergency dispatch, the enhanced 911, and more recently, ITS applications. And I know a number of the students in here are doing research on ITS. So this is really driving the need to have the best data. And what is best available data? It's got to be as current as possible. It should be as complete as possible, as consistent, and as accurate as possible. So that's what we're all striving for. This is just to make sure everyone's awake. Blank slide. So the functions of the transportation framework. This is from the paper we just presented at TRB. The primary function of a common transportation framework is to provide a source of best available, which I just described, line work and attribute data that would be updated periodically, probably on an annual basis. This will support a core set of transportation applications that are common to a sufficient number of organizations to warrant a common database. And this second sentence is key, and I'll show you some of the business needs or transportation applications. Not everyone has the same needs. Some people have more stringent or robust requirements. So in order to provide a common framework, you have to figure out how robust do you need to make this framework. Do you keep it as simple as possible so as many people can use it as possible? The problem with that then is the people who have more demanding needs won't really have any use for that. But if you make it more robust, the people who have simple needs don't want all that data or all that accuracy. So these are kind of the conflicts that we're facing. Then there are several different types of transportation framework. These are kind of all going on simultaneously. The one we're most familiar here with is ARLIS. Is anyone not familiar with ARLIS here? Okay, that's the Metro Regional Land Information System. It actually didn't start as a transportation framework. It was basically a land parcel database, but it also has a very good regional street centerline. Another good framework is Metro GIS, which is from the Minnesota regional government there. And then we have a number of state efforts that are going on. Probably the most ambitious and most successful is the Texas StratMap, strategic mapping, which aims to provide mission-critical digital base maps statewide. And what the state of Texas has done, and you can imagine this, how big Texas is, how many roads they have. They've basically gone out and GPSed all of the roads in the entire state, basically taking a van and driving and using the van basically as a cursor to digitize, literally on the surface of the earth, all the streets. And this has cost several $1 million. So this is kind of the most expensive, but perhaps the best way to do it. But we're also looking at other ways of trying to create this framework instead of basically starting from scratch. And there are some other state efforts. And then at the national level, we have some basically 2 or 3 efforts. One is what's called the USGS National Map. And this aims to provide 7-day accuracy. That means that the map would be at most 7 days out of date. This is about a 10-year down the road project. There's also an ongoing effort to always enhance the Tiger, to take the Tiger Centerline file and improve that. And then kind of the competing and what we've been struggling with over the last several years, we have the government efforts, and then we also have the vendors, the private vendors, the NavTechs, the MapQuests, who are maintaining their own proprietary databases. So we're trying to figure out how do we get or share data with these people, because they're also trying to get the most up-to-date data. So that's one of the challenges that we're doing research on. This just shows the NavTech Centerline to give you an idea of what a private Centerline database would look like. And these are obviously very accurate and up-to-date in the most popular places to travel, less so in rural areas. So and if you don't recognize this, it's D.C., Washington, D.C. So how do we get started with this research? A couple years ago, Professor Duker was involved with ORBIT, which is the Oregon Road-Based Implementation Team. That's a statewide effort with the Oregon Geographic Information Council. And two PSU Metro reports came out of that. I was a co-author on the second one. But unfortunately, due to budget constraints, it was disbanded several years ago. So what do we do after that? Well, this is a table from the first report. Basically gives you an idea of the kind of analysis that we were trying to do, looking at the different, you see the Tiger, enhanced Tiger, different Centerline files, and then the attributes or characteristics of those files. So after Orbit disbanded, we ended up joining forces or joining the IRIC committee discussions. IRIC is the Interorganizational Resource Information Coordinating Council, and another term that we usually never remember, so we just call it IRIC. And that's run by the REO, the Regional Environmental Office, I think it's called. And here the idea is we have all these environmental issues going on in the Pacific Northwest, primary of which is salmon enhancement, which I'll discuss in a minute. And we need to share, obviously, spatial information across jurisdiction boundaries, state boundaries. So that's the reasoning behind this coordinating council. So IRIC is concerned with matching. What they're really looking at, or what we were interested in helping with, was they had excellent hydrography data layers, but they needed road layers, basically where the roads intersect the streams, culverts, and bridges are critical for salmon enhancement planning. And this you can see here. This is actually from a Montana project, so that's why they have bull trout instead of salmon. But here it shows the streams on the hydrography network, and then the roads that impact, in this case, bull trout recovery. So the idea is you need as accurate a road database on top of the hydrography layer as possible. So how do you get that? How do you achieve that? And so that then led to the Washington State Department of Transportation Framework effort. They kind of blasted ahead of Oregon with the disbanding of the orbits. That kind of languished, but Washington then kind of pulled ahead. So we kind of jumped on their train, or whatever you want to call it, and that kind of grew out of the IRIC, and we developed a white paper that kind of synthesized a lot of the institutional issues. We found there was ongoing discussion that was going kind of round and round in circles, and nothing was getting done. So they asked us to synthesize and come up with a white paper that would kind of lead to some finalization of some of these issues so that the state of Washington can move forward. And basically we looked at the business needs. Again, a lot of this is more of an institutional, organizational issue than a technical GIS issue. So we divided the business needs into planning, operations, and management, and then did some basic description of those needs in each of these areas. We also tried to describe the spatial and temporal accuracy needs, because these vary also. Planning is something that doesn't need the temporal accuracy of emergency dispatch, or ITS. And what we mean by temporal accuracy is roads being as up-to-date as possible, knowing once a road is open, that you have it not a year after it's been open, but a month after it's been open in your database, and you can use it. And then the paper helped the group move from discussion to action. So here is a table of the business needs, analysis of business needs for transportation data by application areas and function. Across the top row, we have the different areas: planning, management, and operations. And this gets back to that struggle of designing the framework and how robust do you make it? Because again, each of these three areas have different needs. And then you also see some application areas along the side here. Oregon is also moving ahead. Finally, they've developed a framework implementation team, and they have teams for each of the 7 layers that I showed you earlier. And then for the transportation framework, they've proposed this prototype data structure, and it's the 4th draft. So you can imagine how long it's taken to get here so far. So here are the attributes that they're trying to all agree on. That's one of the big issues. What attributes do you agree on so that you can share your data across different jurisdictions? And one of the key ones is a unique ID, trying to develop a unique ID so that everyone can identify the same piece of road. This is the national effort. This is the USGS National Map. That's getting a big push now with Homeland Security. Again, as it says, border to border and coast to coast, geographic information for the nation. So, and they have a number of pilots going on. One of them is actually on the Washington-Idaho border and around the Spokane area. So again, you know, what they're trying to do is to actually test ways of sharing or not just in this case transportation data, but geospatial data across different jurisdiction boundaries. And now I'm just going to run through kind of what we presented at the TRB. That was about a week ago in nice cold and frosty Washington, D.C. And some of this I've already covered. So basically in this paper that we wrote, we were looking at transportation data sharing issues in the bi-state region of Washington and Oregon. Again, each state is going their separate way, but we also want to figure out a way, since we're so close and we are kind of in the same level, of making a unified effort at creating a framework, transportation framework. So again, salmon enhancement planning was one of the major issues, and then the other bi-state road data needs. And then this is all taking place in what's called the NSDI, National Spatial Data Infrastructure Framework Data Context. And those were those 7 layers that I showed you earlier. And then now it's being pushed by Homeland Security. As we're all aware, anytime there's an emergency, we need to be able to get coordinate the information for disasters or whatever occurs. So again, the scope of this paper then was, or the framework rather, is compiling of best available line work. And then what we're moving into now, and what I hope to talk to next spring, is the more detailed and more important updating and maintenance process. What Professor Duker found was that there was a lot of talk and a lot of effort going into building a framework, assembling this data, but not much on actually updating and maintaining it once it was created. So again, the requirements of a framework, we're looking at how much spatial and temporal accuracy do we need, and how current, complete, and consistent it should be. Some more of the state efforts. These big states now are migrating what were formerly mainframe highway inventory systems to GIS. And the key states here are Arizona, which some of us discussed in a class last term, Minnesota, Wisconsin, again, the Texas strat map. And what's interesting is Maine, among a number of New England states, and I believe they can do this because they are small and rather rural. They're now creating this framework for E911 mapping using GIS, basically the enhanced E911 that's being driven by cell phone usage. So they're going out and doing this not so much for their transportation needs, but to get the most accurate transportation center lines for E911 and emergency management. Again, an overview, we have the USGS National Map program with their rather lofty goal of 7-day currency objective. So that's about a 10-year out or even more. There's also competing, or not really competing, but a separate geospatial one-stop. This is part of the e-government initiative, and it's designed more of a portal, allowing people to access this data in one place over the internet. And again, we also have the vendor databases that are in a way competing with these government efforts. So part of the process, part of my research then will be looking at the institutional legal issues of sharing data between governments, and private vendors and citizens. And again, this is all, a lot of it's being driven by address geocoding and navigation needs. So we kind of threw out this proposed framework concept related to the Washington State effort to compile roads framework that has a limited functionality to meet common business needs of participating organization. Again, the more robust you make it, the more difficult it is for other agencies to use it. So you're kind of looking for the common denominator. So one idea I had, though, was to come up with 2 frameworks. But at the moment, we're looking at just one framework that will kind of go through the middle ground. And then we're going to create a clearinghouse of these new and modified transportation features. And this clearinghouse is going to be run on a transaction-based concept, where versioning, you basically recreate your entire data set. Transaction-based, you just take the new parts and add it to what you already have. And it's also day-forward implementation. We're going to take what we have and just add every new day the new data. Okay, nice graphic here. We have building and maintaining the transportation framework roads. This was developed by Professor Duker, so he's best at explaining all this. But basically the data flows down from the top of the diagram down to the bottom. So you have your GIS source material and project data from transportation organizations. And then it flows into the transportation framework, and then it comes out the bottom end distributed to users who may need the data. This is a more detailed application of that. Some of the conclusions, it's basically a synthesis of issues and alternatives. And we have a dual framework. We want to build an initial framework, and then we want to institutionalize a systematic process for updating and maintenance. And that's pretty much what my current research or efforts are at Metro. And then there's also an ongoing need for pilot projects. Future directions, integration of new modified transportation features, location of construction projects, and then location of traffic accidents for real-time navigation. And this is where the ITS comes into play. And then this is a model of the updating. Again, we have kind of 2 separate issues, developing the framework to begin with and then updating the framework. And this shows how updates to the transportation system from many state and local governments would flow through a system. Basically, there are 4 different sources of updates: exactions and permits, work orders to public works crews, your capital improvement projects, and then again the ITS, the traffic probes, loops, and cameras. And then this shows the flow, proposed flow of the information, the new data. Okay. Are there any questions?
Actually, Paul, I have a question.
Yes.
I think you've done a good job at describing, particularly to me, as a sort of a non-GIS person, that you have there's some technical issues, but there's largely a lot of institutional issues.
Right, right.
And I'm wondering, there's been a lot of groups, and I'm guessing interagency groups that have been tackling, with lots of acronyms, tackling these questions. And I guess I have 2 questions. The current group, and it sounds like it's a Washington, Oregon group, perhaps?
The IRIC. The
IRIC. What agencies are involved in that? But then also, in terms of long-term, it appears to me that someone has to be in charge of this somehow, particularly for maintenance, and maybe give your opinion in terms of the appropriate institution or organization, or who should be the lead, if you agree with that.
Yeah, well, to answer the first part of your question, there are a number of groups that have been kind of coming to the table off and on. And this is one of the big institutional issues. It's the question, what's in it for me, or what's in it for my organization? So you have a number of the big federal players are the Bureau of Land Management and U.S. Forest Service. Then you have local counties, and then the local jurisdictions. Excuse me. So does that answer your first question? Again, they kind of come and go to these meetings, so it's hard to keep track of who's there.
Just procedurally, who organizes that? Or
the IRIC is by RIO, the regional. Is anyone familiar? Okay, I really don't know much about them, but it's the Regional Environmental Office. I believe they're responsible for coordinating most of the Northwest environmental planning, the forest plan, salmon enhancement. So, second part of your question. It really is confusing. I mean, I think one of the good things that I've been doing, I've had the time to kind of sit down and try to track these efforts. Even people who are involved can't keep up with all the different framework efforts. Because again, you kind of have, there are about 20 states that are going off and trying to accomplish something. But then you also have several federal efforts. So, yeah, I mean, who's in charge of this? No one really knows. So, there's the federal efforts, but as we all know about the U.S., we're a federation. The states have their own power and also try to go and do their own thing. So, but the federal government is trying to get the states to kind of cooperate, but I'm not sure yet. Yeah, I wasn't sure how long this was going to take, so I have a lot more I can talk about the next time in terms of the institutional issues. So, David, hold that.
I have a question about your flow chart that you had towards the end, where you have is the previous one. There you go. Where you have basically you have all these inputs from various agencies. Actually, was there a previous flow chart?
Yes.
There we go. You have all these inputs from various organizations, and it's ultimately going to the infrastructure management. However, my experience at the City of Portland, it was the infrastructure management demand, the end user demand, that basically generated or forced the other agencies to create a GIS. Basically, the people who have to maintain the streets wanted to coordinate their efforts. And so I'm wondering, when you put together this model, I realize it was put together by several different people, including yourself. How did you rationalize the model? I mean, what's experience? Was it purely theoretical, or was it based upon experience of other agencies?
I think, yeah, it's largely theoretical. I mean, this was pretty much Ken's effort here, and Ken's, obviously been doing a lot of work and visiting people. But that's one of the reasons I'm actually working at Metro and trying to work with Hillsborough and get actually into the nitty-gritty of how this will work, instead of just kind of theoretical, well, this is how we like it to work. So, and what I'm finding is that right now it's very ad hoc. I think I talked with you earlier, I've been doing some surveys to find out how different agencies, different governments in the region do this updating, and it's very ad hoc. There is no good streamlined process yet, so that's what we're working on and what I'm in particular and hoping to learn about and improve. Did that answer your question, David? Yes.
Paul, mine is kind of related to Jennifer's question too, as far as the upkeep of this system once the framework is kind of created and agreed upon. Is it something that would somehow be centrally located, or would be centrally located like amongst regions of the country, or is there a vision as far as kind of how it's going to exist in space and
No, I don't think there is yet that agreement. You have the several different efforts. You have the geospatial one-stop, which is kind of the portal idea, where it's an access point to data that's out there, not in one centralized area. Kind of similar to Esri has what's called the geography network, I think. So yeah, that's another institutional issue that you have centralized versus decentralized, and there are a lot of new computer applications that I'm not very well versed in that will allow agents to go out and search through the web and find data. So Professor Kimple could probably tell us more about this, but so there's no agreement yet. There's no standardized. So that's why I'm taking a course in technology management, so I can learn about this. So, yes.
You had a slide up there with a list of different issues, and you said we've talked today mostly about transportation.
Yeah.
I'm curious, what are the hopes or the effects of this structure on other kinds of tracking, of updating, say, spread of invasive species? What's like raster data and things like that?
That's a good question, but I think we've concentrated on transportation. Well, one, because we're transportation people, and two, transportation is kind of unique in that you have this overlap where a transportation feature can cross several different jurisdictions. It can be owned by one agency, maintained by another, and I don't think you have that same kind of issue with raster or parcel database, because it's more, what's the word I want to use, but does that answer your question? Or
well, I guess specifically I was curious, and there's a big focus on updating and having it very current, and I know things change in raster features, ground cover, Are there any are you learning anything from attempts in that arena to have a system that quickly update and keep it?
No, I actually haven't looked into that area, but what I know is that using satellite imagery, Landsat, things like that. So that's a good area to look into. How that is that a area you're familiar with, or?
Well, I took GIS 1 last quarter.
Okay. Well, I meant specifically like environmental data. So, Allison.
I have a two-part question, one related, one not so related. Is this transportation framework also coordinated with sewer and utility systems, or something that would run beneath the linear framework of the transportation system?
What I guess you're talking about is called AM/FM, automated mapping and facilities management. Not really. We really haven't looked into that aspect of it again because it is underground. So.
And my second one is, when this is all said and done, and say we have the perfect database and we have all the data that we need, what, in your opinion, do you think will be the most profound effect on transportation planning or transportation issues as we know them?
Well, I guess one of the driving effort is the emergency management. The mantra is getting that ambulance to the right place faster to save lives. That's kind of the one of the key selling points of that. Or in navigation, not driving off a bridge because of your in-dash GPS didn't realize that the bridge was closed. That's the example I read about a couple of years ago. So, does that? I don't think there's going to be profound.
But what is your personal opinion? What do you think will be the most profound change? How will we use this data? That's so different than how we use it now.
Well, like anything with computer and data, the better computers we have, the more information, the more demanding we are of the data. Then, now that we have GPS and we can do all this navigation, 10 years ago it wasn't that important to have the most up-to-date maps because we weren't driving around as much with our in-dash navigation systems. So I guess I don't really have a good answer for that. But challenging questions. Charl.
I don't know if this is challenging questions. Maybe it'll be easy to answer.
I need an easy softball question.
Yeah.
So
You mentioned that it will help business needs, also like capital improvement plans. And I just saw the word capital improvement.
well, not so much help, but this is the how we divided our typology, let's say.
But anyway, the basic question is, how will this National Transportation Framework support decision-making for capital improvement projects at county level? I mean, I'm thinking maybe of getting a better visual you can get a visual thing what's going on in the region, on regional level, at national level. Do you think it will help decision-making at county level for capital improvement projects?
Yes.
And yeah, okay, but actually, yes, and how?
So you're trying to. That's for you to answer. I really don't know. Ray.
Slightly more esoteric. Why do you want to go to a transaction-based instead of versioning for your data? A. B. Have you considered investigating methods that are used by natural resource people when they have to do their updating of streams and stuff, because transportation GIS is essentially the same as natural resources, because they're just linear features going across a landscape. And there might be a C if you answer A and B.
Well, the transaction updating was Ken's idea. Again, much of this, I'm kind of Ken's research assistant, so I can't take credit for a lot of this. But basically, from how I understand it, versioning, you basically have to recreate, like rewriting the entire database or data set. Whereas transaction, you're just kind of taking, you're adding the new increment or the new change to that database. So to me, that would seem to be a lot easier, a lot more efficient method of updating. Are you satisfied with that, or?
It's just an opinion.
Okay.
I could argue, versioning is better than transaction just because you can go backwards easier and you can recreate, in planning you don't always want to just go thump, thump, thump. You might want to go back to a certain time and recreate.
That's a good point. Okay, and your second question?
Had to do with looking at natural resources
right.
and how they deal with the same issue.
Well, my pat answer to that is streams don't change as fast as roads do, or you don't have new streams as frequently as you have no new roads popping up in a subdivision, or new road construction that's drastically altering your road network or street network. Is that a good enough pat answer? Is there a C? No. Okay. Yes, you had your hand up.
I was wondering what possible time frame that you've heard or that you would place for, let's say I'm traveling down the freeway and I get an update on my GPS monitor to say that there's a traffic accident 5 miles down the road and that it should reroute going a certain way.
Mm-hmm. I'm sorry, I missed the...
So what real-time information that I get on my GPS monitor in my car,
right.
What time frame would you say is in the future for that application coming to fruition?
That I couldn't answer. We have some ITS experts in the room who may want to take a stab at that. Any engineers want to speak up? That's not my area of... I'm sorry? Soon, yes.
And the only thing I know about that, I don't know on in-vehicle on-start ins and outs at all, but I know that, through ODOT and, there's stuff locally that does kind of up to date and kind of almost real-time incident management, but you have to kind of be able to get to their website.
Yeah.
So I don't know how integrated it is with the in-vehicle stuff yet, but I know that we're getting closer. And, with like TriMet and Transit Tracker, they're tracking the buses so that they know that it's 2 minutes to your stop or whatever. And so I feel like it's much closer, but we might not be in vehicle yet.
Yeah, I have this. This is for the next presentation. We're getting more into the updating process. So this is actually the Puget Sound. You can download this to your home computer or even your pocket PC, and this gives what we call random stochastic updates of congestion, and you can get literally real-time data by links on the major interstates, and you can see by the legend. This just gives basic, but if you actually go into the website, you can get the capacity, the speeds on the links. So it's out there. I don't know if this is available yet in the car, but it's available on the internet. So and this is a preview for next spring.
Any more questions?
I was just going to add something to that in response. Is
sure.
It might help less if you're going on a highway than if you're driving on a brand new street, because the brand new street won't be updated unless your work is successful.
Right. Exactly, and that's where the pizza delivery comes into play. We call it. Well, Ken calls it. I forget the term. Updating by trial and error. Where people who and then this is what I did. We come back in from our deliveries and say, it took me 15 minutes to find that house. Because it's on a street that's not on our map, and then we go in and draw it in our big map on the board. So we want to improve that. So everybody can share those updates. Pizza Hut knows where all the streets are because they got drivers going out there every day. 20 drivers. So how do we get those updates available to everybody, not just whoever's doing that?
Actually, you had a question first.
Yes, Lance.
Yeah, my question kind of builds off of that. It seems like local governments and jurisdictions are kind of stumbling over each other to set up a standard. Do you think there's opportunities out there for private industry to come up with models? Because it seems like there are a lot of businesses right now that have their own databases. Yeah,
and what they do, one of the big ones is GDT, and they have what's called the Community Update Program. And again, this is kind of where we have all these not conflicting, but different models. Community Update is where GDT goes to a local jurisdiction and it says, okay, you have this whole hassle of updating your little piece of the pie, your streets. We'll take care of that. You give us the information, we'll manage it, and then we'll give it back to you. But the trick there is no one else can use that data. See, GDT wants that, so they kind of have this, they have this factory, we call it this, I'm sorry?
Yeah, that they can sell it.
Right, exactly, yeah, they want it. So, and the cash-strapped governments, it's like, oh, hey, we have someone who will maintain our data for free, and they have to come to us anyway because we're the source of the new updates. But with this agreement then is proprietary database issues and legal issues. Basically these local governments have to sign licensing agreements basically saying that, no one else can use this data except, maybe a consultant or so. So this is some of the institutional stuff, the legal aspects of geospatial databases.
Quickly, that national map again, was that something that's a direct product of the Homeland Security Act, or just that's gaining momentum because of the? It's
basically the national map is starting with, I think it's like 150 cities based on the Homeland Security. They kind of pushed that through to start with the big urban areas.
Was it in motion before the Homeland Security Act, or you know what? Don't worry.
Yeah, I think it was. I first heard about it. I think in
I'd never heard of it before.
Yeah, like 2000. The years are kind of blurring for me now, so I forget when it was that we came across that.
Just a small question. So, and the Pizza Hut thing, maybe. So, UPS, FedEx, those folks, do you know if they purchase their map? I assume that they have good maps.
Yeah.
Do you know if they do anything in-house or if they're purchasing from people like GDS or whoever?
That I don't know. There's so many vendors out there now. Just about every big corporation or every retailer, you go to their website and they have a mapping application that will show you, not only where their store is, but how to drive there. You can go to MapQuest and have all the McDonald's across the country mapped, if you're driving across the country. So I don't know. I just bring up Pizza Hut because that was my experience. And so.
The little GPS units on all the pizza doors.
Yeah, that was, yeah.
That one house that keeps ordering pizza. You know where that is.
I remember another thing from PDOT.
I'm sorry.
Oh, sorry. When I was at PDOT, we also had a problem with streets that didn't exist.
Right.
Paper streets. That is, there's we purchased the right of way to put in a street, but a street was never put in. There's numerous examples around Portland of that, and in any other city for that matter. And so my question is how do you account for that in the system? When we give Centerline data to Metro or to the private companies, they immediately publish it, and we see paper streets in the phone directory, which is totally useless for anybody who's trying to get around. And so I'm wondering, have they considered that in the system?
What David is talking about, if you ever look at maps up behind OHSU, there's a grid network, and if you ever go up there, the streets aren't there. They're part of the park. Actually, we're just behind Professor Duker's house. But yeah, next time you look on the map, see if that's there, and they don't exist. But a lot of what happened in the past, subdivisions were platted. A lot of Forest Park was going to be a huge subdivision. But I don't know the answer to that question. I talked a little bit with Ken about rights of way, but we really haven't addressed that issue in detail. So I don't know how that's handled, other than someone getting rid of them.
I may follow up. Unfortunately, those rights of way do have oftentimes sewer lines through them, and utility lines and that sort of thing, because they are public right of way.
Right.
But they have no streets, and there's no intention of putting streets. And Forest Park is a classic example of that, as well as that area behind OHSU.
Yeah.
So if you have a system like when we're talking about the utilities and that sort of thing, it often goes in. The utilities follow the street network.
Right.
Then you have that problem. This segment has no street, but does have X, Y, and Z utility. And so, it's something you have to consider in any system.
Yeah, that's one of those little kind of on the side issues that we haven't really gotten around to addressing. So, but I understand what you're talking about, integrating, the utility updating with right away.
Any final questions? Thank you very much, Paul.
Thank you.
If you want to check, I think I got all of you who verbally asked the question. I wrote a little cue here. You can check. You can also check if you didn't check in.
I hope that wasn't too short. I didn't have a chance to run through it. So
Yeah, no, that's fine.
Okay. But I have more. I had a whole bunch
It's very
of.
well organized, and I appreciated your sense of humor that you added to it as well.
Sure.
It was good for me, not being
Good job, Paul.
not
Thanks.
a GIS person. So it was useful.
I think I got you now. I saw you walking. Okay.
Yeah. Surprised you were presenting today. I finally actually looked at Alice didn't come. And then I checked the sheet who was presenting and what his presentation was, and I thought, probably not done.
I have another question. I was wondering if this was technology that we use in conjunction with disaster scenario modeling and how to improve response times for emergency vehicles. And is this technology being used in conjunction with disaster scenario modeling?
Well, this really isn't a technology. It's more a framework, a process of getting data that already exists. So I don't know so much about the actual technology, Can you be more specific? What do you mean by technology?
With the
like you mean web serving?
Well, there's certain disaster scenario models that the federal government and state agencies use to try and improve response times to.
So this can help. Yeah, this. So in that context, having the most up-to-date